Hello Year 12s. In this video we are going to look at how to integrate using a known derivative. And this is for Learning Intention 37. This is a classic exam question. Absolutely classic. And I'm going to show you how to do it. So this is example 1 here, taken from the textbook. This is example 2 here. So this is example 1, this is example 2. And the idea is, I'll show you with this. We'll start with example 1. We'll jump right in. The idea is that if you already know a particular derivative, then it makes finding some integrals a bit easier. So the first thing, they give you an equation. So they give you cos 3 minus 4x, and they ask you to find the derivative. Find dy dx. So you're given cos 3 minus 4x, and we're going to find the derivative to start off with. So let's do that. So it's the chain rule, diff of the outside, so cos diffs to negative sine times diff of the inside times the negative 4. So that's 4 sine 3 minus 4x. So what it's saying is, given that you know this fact, given that dy dx equals 4 sine 3 minus 4x, given this, find the integral of this. So the whole aim of this exercise is to integrate this second one. So the whole aim is to find the integral of negative 2 sine 3 minus 4x. But you'll notice, hang on, I can't do that with any of my known strategies. You'll think, what? How am I meant to do that? How can I integrate that? I don't know how to do that. However, you have this piece of information here. You have this piece of information that's going to help you do it. So what you need to do is adjust this to make it look like this. So adjust the derivative to make it look like this. Let's do that. So we can say that dy dx equals negative 2 times negative 2 sine 3 minus 4x. Yeah, because negative 2 times negative 2 is 4. And we've got that negative 2 out the front. Now we're going to divide both sides by negative 2, and we get negative a half dy dx equals negative 2 sine 3 minus 4x. And this is where we say, hang on a sec, we can replace this over here with this. Negative 2 sine 3 minus 4x can be replaced with this substitution. So let's sub that in. We've got negative a half times dy dx. Well, what do we do then? Well, that's a coefficient, that's just a constant. So we can pop that out the front. Well, what do we do next? Well, the integral of a derivative is just y. That's one way to think about it. Another way to think about it is that you can cancel the dx's and be left with negative a half the integral of dy. Now you can always assume that there's like a 1 times dy, so that equals negative a half y. So a couple of ways to think about that. The integral of the derivative is just the original function. If you integrate the derivative of something, you get the original function. So I don't know, like if you integrate 2x, you get x squared, the original function. So the integral of a derivative gives you back the original function. Here, the integral of the derivative gives you y. Well, now we can sub y in, because we know what y is. So where's y? Well, we've said that y equals this stuff here, because we're finding dy dx. So we've got negative a half cos 3 minus 4x is our answer. So the integral of this is this, and let's plus c. How can we check that? Let's go over to CAS. Let's check our answer. Oh yeah, we've got it there. So we want to integrate that, and we want to see if we get that answer. Calculate, shift, plus negative 2 times trig sine 3 minus 4 times x. Close our bracket. What's happened there? Yep, dx. Let's see what we get. There we are. We get this answer, this negative half cos 3 minus 4x plus c. Now they've written 4x minus 3. It's the same thing, because the cosine function swallows the negative sign. So what they've done is, what the CAS calculator has done is it's gone, I'm going to take out the negative, and then cos swallows negative signs, so you get cos 4x minus 3. So both are fine. So what they're saying is, I'm going to give you this key bit of information and you need to integrate that. So I'm going to spell it out a bit more clearly with the next example. So what they're really saying is, find, no, I'm going to phrase it better. So what they're really saying is, given y equals the natural log of 5x plus 2, find the derivative. Find dy dx. Hence, and that's where the hence comes in, hence find the integral of 20 on 5x plus 2. So they're saying do this routine procedural bit and then use that piece of that hint we've given you to find this integral. Well, let's do the first part. Let's find dy dx. Dy dx is the diff over the original, 5 on 5x plus 2. Now we want to find 20 on 5x plus 2. Well, we need to make this look a bit more like this. So what you need to do is say, well, you've got 20 on 5x plus 2. How do we get the 20 to 5? Well, that's timesing by a quarter, because 20 divided by 4 gives you that 5. Then you times by 4, so 4 dy dx equals 20 on 5x plus 2. Then you can sub, you can see that that's the same as that, so you can sub this into there, equals 4 dy dx dx, which equals 4 the integral of dy dx dx. So that whole thing, the integral of the derivative, is just the original function. So that's y. So that's 4y, and we said that y equals that. So the answer is 4 natural log of 5x plus 2. I'm going to plus a c. Alright. get comfortable with integration first. So if you're not comfortable with everything we've done before, make sure you're comfortable with that. Once you're comfortable with everything, have a go at this. These are very common exam questions, but it's borderline kind of specialist maths here. So they're using some workarounds to make it methods. They're giving you hints. So in specialist maths, you would just be expected to figure out how to integrate that and figure out how to integrate that. In methods, they're saying, oh, here's a little hint. Find this derivative and it'll help you out. So if you're unsure, make sure you can do all the other stuff first and then have a go. Do your best with it, and if you have been, thanks for watching.